In this video, I'm going to talk about the spectrum test. I'm not going to get into things like the attenuation settings or the generator settings or any of those because those are done in separate videos. So this is just discussion of the spectrum test. And the spectrum test is the most common test people run. On the bottom is the frequency, and on the left is amplitude. And so what we are charting here is the amplitude of every single frequency in the spectrum of interest. And by doing that, we get a lot of information about the signals. It is in the operation of the equipment we're testing. So normally this is done with a sine wave. I'm running at 1/10 of a volt, so honestly I can turn off auto range and just set the attenuation to 0, and we'll get a consistent noise floor for the demonstration. So let me begin by running this. When you click run, it starts and then it just keeps running. And I have it set to 3 averages, so as you saw, and we'll do this again, it starts with a fair amount of brass noise and then it gets smaller and smaller until the third. And if we increase the number of averages, it'll get pretty darn skinny down here, but you're not really getting much extra information other than we can see the peaks pretty nicely. And those are what's important. So when you're looking at this graph, the peak in the center is the fundamental, the sine wave frequency. And we expect it to be at the amplitude of whatever device we're looking at's output. The other peaks are all distortion or noise or you name it. They're not good things. So this is a pretty good analysis. And as an example, I have this really nice preamplifier that I'm testing. This is the preamplifier output. I've set the gain in it to approximately 1. So it's about 1/10 of a volt in and 1/10 of a volt out. Now, I have replaced all the caps in the left channel, but not the right channel. And so when you look at the two spectrums, they are pretty different. In particular, they're very clearly different over here on the left in the power line hum areas where the capacitors will tend to make a lot of difference. And on the right, it's a little hard to tell at the moment because of the way the palette is set. And that's fine temporarily. If you really want, you can go to the palette, change this, and make it a little bit transparent. And now we can see underneath the red, and we see that the distortion figures are not that different, but the noise figures sure are. And a really nice way to see that in the spectrum test is to start turning some of the chart pieces on. So for example, let's turn on power markers. All right, now on the left channel, we have a little dot showing us the height of 60 hertz, 120, 180, 240, the first 4 power harmonics. Well, counting the fundamental. And up here in the markers, we show the values of the hum. Now, if you would like to see this on the right channel, we only show one channel of markers, but we can just simply turn off the left channel, and now the markers will show the values on the right. So we can see, for example, 120 is at minus 122, and here 120 is at minus 128. So the capping sure seems to have done a lot of good on the fidelity or the amount of hum in this case coming out of the preamplifier. Now on the right, we have the distortion figures. And we can also turn those markers on. Those are in the light blue. I'm not a fan of light blue. Let me stop this for a second. And now if I mouse over here, we'll see that that light blue is palette index 16. So let me change that to like a deep red or maybe a bright green. Okay. All right, let's go back to running. All right, a little bit easier to see. All right, so here are the harmonics of the signal, and some of these other things that it isn't marking are noise from other external devices. Like here's a peek at something. Now, how can we find out where that peak is? The easiest thing to do is zoom in a little bit. And as I move the mouse around, you'll notice that there is a red dot showing up. And actually, we can change that color too, but so let's expand that, expand this a little bit, and click there, and we're at 1500 hertz, which pretty much has nothing to do with the fundamental unless there's some large intermodulation with a 500 hertz signal. And do we see one of those? No. So likely I have something generating this, which is honestly pretty low level interference, and it seems to be common to both channels, although the left channel is doing a better job at suppressing it than the right channel. But to go back to the distortion figures, here are all of the distortion harmonics and the fundamental. So we can easily see the values here. We can do this in some sweeps, but even in the spectrum, it's pretty easy to see what the distortion looks like. And by looking at the bars, we can see that the blue, the left channel, is lower than the red pretty consistently, which is a feature of making the red slightly transparent. And again, if you really want to see the numbers, you can take a look at this picture for a second. Let's start running this. And then turn off the left channel, and it will switch to showing us the right channel values, which are noticeably higher. All right, so we've already seen some pretty good things we can do with the spectrum test. And in many cases, frankly, that is much of what you do. Now, what's really nice is we can get some actual numeric output here, even though these are sort of graphs and we're looking at that stuff up here. Let me turn off the markers and turn on summary data. And like most of the boxes in a graph, I can move these around. And what we're looking at here is the left channel in blue and the right channel in red. And note that the little dot, by the way, just sort of sits here and tracks till we do a stop, and then we can move it around. And if I click, it will stay fixed and just start tracking that frequency. But anyway, so these two boxes show us an awful lot of information about this signal. And if you mouse over any of the values, it will tell you exactly what you're looking at here. So the total harmonic distortion is 72 dB down in the left channel. It is 67 dB down in the right channel. The recapping has done just a really good job. THD plus noise is way better. The noise is a bit better. And we also get the second through sixth harmonics. This is equivalent number of bits. Signal to noise ratios. So these statistics are really nice, and they work not only for this, but they work if we get an old test. So let me turn off the right channel and let's get a prior test. I had swapped the cables to see what was causing the issues. And what I saw was that even with the cables swapped, the left channel is pretty good and the right channel is way noisier. But the other thing you notice is when I do this, if we look at the right channel data, it's showing the visible gotten data. So it's really nice to see the data summary boxes. It will only show two because they start getting way too busy and confusing. But look at two charts and you get two of these. In fact, if I turn off the left channel and turn on only the thing I've gotten, it will show me the statistics for both of these. So I can compare pre-swap, and by just simply showing left and right, I can compare post-swap. So that is an awful lot of what you get out of a spectrum display.